Yeah, we're looking at this question. Find the method of use the method of variations of parameter to solve this second order differential equation, which is non-homogeneous. So as we all know that the first step to that is to get the homogeneous part of the equation. Okay, and the homogeneous part will be equal to equating this differential equation to 0. And after that, we get the auxiliary equation. The auxiliary equation, is r squared minus 9 equal to 0. As we all know that we always use the second differential. The differentiation will be r. If it's second, that will be r squared. If it's a first differential, that will be r. Okay. Then the constant will be the attachment to the y. Okay, the one without a differentiation, that's 9. The attachment to your y is your constant for the auxiliary equation, and this will be this you can factorize this, which will be equal to minus 3 into bracket r plus 3. Okay, equal to 0. Then r equal to what? 3 or minus 3. Okay. Then we can get the solution for the differential equation. Y1 will be equal to, let's take the smaller one, that's e minus, this differential equation is a function of t. So that will be equal to e minus this, c1, one is this, and y2 is e3t. Okay, that's the solution of the differential equation. And then the homogeneous equation, okay, the homogeneous solution, the homogeneous equation will be equal to c1 equal to e minus this plus what? C2 e3t. So that's the homogeneous equation. That's the homogeneous solution. Then the next thing to do is to get a particular solution. Okay, and in this case now, for variation of parameter, it has its own formula, which is this formula. Okay, we've already gotten y1, we know y1, we know y2. Okay, so in that case now, where you don't know v1, you don't know v2. So v1 is in form of formula, is a function of x, which is equal to what? Integral of minus f of x. But in this case now, it's not going to be f of x. This here, the function here is a function of t. So that will be equal to f of t. Here will be f of t, differential, second order differential equation. Okay, so that's A is 1. The Wroskian, we need to get the Wroskian, but let's get the V2 also. V2, this is the formula for V2, f of t, sorry for that, f of t over the Wroskian, A times the Wroskian of the linear y1, y2. Then this is y1, this Wroskian of your linear y1 of the y1, y2, which is the solutions of the auxiliary equation. And then this is the functions of t or y1, then dt. Okay, the Wroskian will now be equal to Wroskian of linearly dependent solution be equal to e minus this, that's y1, e3t. You get the differentiation of that. Okay, that's minus 3, minus the 3, e minus 6. If you differentiate this one, okay, the derivative of the power is minus 3, so times the function itself. So this will be 3 e this. Then you can, this is determinant, okay, so this will multiply this, and that will be equal to 3 e 0, okay, then minus into brackets minus 3 e to the power 0 or so, that will be equal to what? 6. That will go to 6. And don't forget that if you multiply e minus 3t times e 3t, it will be actually e to the power 0. So the Wroskian is 6. We've gotten the Wroskian of the we've gotten that. Then we can go ahead and substitute and get the v1. Or v1 is the minus we have there can go outside as a minus. F of g is this. This is my f of g. Okay, that's the f of g, and that will be equal to 90 over e 3t. Okay, all over the Wroskian, that's 6. 1 times 6. 1 times 6. Then the y2, my y2 is what? E3t dt. So this one and this one will cancel. So I'm having integral of this, your 9 can go outside, so minus 9 over 6. Your 9 and your 6 can go outside. Then you have integral of t dt. Yeah, and that will be equal to minus 3 over 2 t2. If you integrate integral of t, that will be over 2. Okay, and that will be equal to minus 3 over 4 t squared. Okay, and don't forget, when you are doing your v1, you won't put plus c for that integration. So v2 also will be equal to integral of f of x 9t over e to 3t. Then your y1 is e minus 3t dt 1 over 6. Okay, 1 times 6. Okay, then this one and this one become 1 too. That will become 1. That will be that we now have now this 6 we can go outside. 1 over 6 into brackets 90. This one will become e minus 3t, and then minus this also, minus this, minus 3t minus that, because we are dividing, and then the t. So we can bring this 9 outside, and that will be what? 9 over 6, and that 3 over 2. 3 over 2 integral of t e minus what? 6t dt. So with these two functions now, and as a product, t times this, okay, and that will call for integration by parts. That will call for integration by parts. Okay, so whereby we're going to make u to be t. Why? Because it gets simpler on differentiation. So u is what? U is t, and then the u is equal to what? The t. Then the v is equal to what? E minus 6t dt. So then you can differentiate that. You can integrate that and get your v. Integrate that and get your v, and that will be equal to minus 1 over 6 e 6t. So that's on that. So the next thing to do now is your formula for integration by parts, which is b the u. So I'm using this one, and that will be equal to my uv is uv, that's minus 1 over 6 e to minus 6t. So we have a uv, this is our uv, then minus integral of v, integral of v, which is minus 1 over 6 e minus 6t. Okay, the u, which is dt. Okay, and that will be equal to minus t over 6 e minus 6t. And then this one, 1 over 6 can go outside, have a plus 1 over 6 integral of e minus 6t dt. And that will be equal to minus t over 6 e minus 6t. Okay, then plus 1 over 6 e minus 6t over minus 6. Okay, so then we can do the final. So b2 is equal to minus t over 6 e minus 6t. Then 1 over 6 times 6 times 6, so that's the plus times minus, that's minus, and that's 1 over 36 e minus 6t. So that's the b2. The yp now, the particular solution, will now become b1, and b1 is what? Minus 3 over 4 t squared. That's a v1 times y1, which is e minus 3t, then plus v2, which is what we have here, times y2. y2 is e 3t into brackets minus 1 over t over 6e minus 6t minus 1 over 36 e minus 6t. Okay, so that's that on the particular solution. That's a yp. That's that on yp. Then we can get the general solution. And get a general solution, which will be yg. General solution will be equal to the homogeneous one and then plus the particular solution. Okay, so we can get that and add them together. So and what that will be equal to c1 e minus 3t plus c2 e 3t and then plus your yp, plus your yp, which you have above here. So that's that on these questions.